Hey, good morning, everybody. Welcome to today's webinar. Today we're actually going to be talking about something a little bit different. We're going to be talking about hybrid networks and kind of what goes into that and what are we talking about and maybe how do we actually accomplish that or pull that off and some different practices or different ideas of how to do that. My name is Dan Tolley with ESTeem Wireless Modems. See some familiar faces out there. I see some new faces. So as we kind of step into this series, just to kind of catch everybody up, is we kind of have a two-part series and we do two different webinar type events every month. We have kind of a hybrid or a network setup to where we're going to do a little bit more of a lighter dive into kind of the general concepts of it, kind of a webinar, and then we get into a NetLab series in which we go into a little bit deeper dive into the initial configuration. They're spaced a couple weeks apart, so it's kind of a whole series. I mean, kind of jump in, jump out wherever you want. Hopefully it can be a great resource for you. So as we kind of get things rolling today with this hybrid network to kind of catch everybody up to speed. Like I say, we've got some new people out there as well. So as we kind of start looking forward at this is who the heck is ESTeem? Just to kind of let you know who we are and where we come from in terms of presenting this information. This is a company we've been around since 1982. So we've been around for a little over 38 years in which we've designed, implemented wireless networks, and then we actually manufacture the devices. Now, one of the things also that differentiates us from a lot of our competitors is we are the manufacturer. So we design and manufacture these specifically for kind of the rigors or the challenges of industrial automation. It's usually into a much harsher environment, extended temperature ranges, we're dealing with vibration, things that those devices for more the commercial market just can't withstand. So what this also means is, as the manufacturer, is that we control all the IP. This is both from a hardware level as well as the software level. And so what that also gets you is that we can control the life cycle. And so we're not really at the mercy of somebody else's design. What that also means is that we can go in and actually design these to be backwards compatible. So that the products that are coming out today are designed to be backwards compatible with the equipment that was sold, say, years ago. And that's important because when we get into the industrial automation markets, number one, they're not incredibly fast moving, but the other one is it's a sizable investment when they start rolling out these networks. We want to ensure that no one is left behind there. Everything is made here in the US, out here in Washington State. We're headquarters as well as all the manufacturing is done out here. And really kind of what we manufacture or come out with is really we've got the industry's most complete portfolio. So we kind of cover both sides of the spectrum. We have FCC licensed frequencies. This is your 150 to 174, 217 to 220, 450 to 470. Then there's even a 4.9 gigahertz frequency that sits within that licensed world. Then we get into the license-free frequencies, which is your 900 megahertz, 2.4 gigahertz, 5.8 gigahertz. This is primarily where we've been talking about within kind of this series. Because this is really kind of where everything is evolving due to the speeds and some of the flexibility and not having to do the licensing. But today we've got a little over 45,000 modems in service worldwide. Predominantly we're in the Americas, both in North America as well as Latin America, but we do kind of stretch the globe. And kind of where we fit is we really have our solutions into kind of these main heavy industries, a lot of water, wastewater, oil and gas, mining, material handling, power and energy, agriculture. We have infrastructure, we have factory floor and AGV use. So we really kind of are involved in a lot of places. And what we're seeing is within all these industries is everybody's going through this digital transformation. And when we kind of stop and take a look at that, we're really moving from a serial-based communication scheme, which was really designed to be device-to-device level communications. As we're transforming now, we're kind of migrating into this Ethernet-based system. Now, there's kind of two things to look at there. Number one is we're moving now, not only the data itself is being structured differently, but the idea is going from a device-to-device level communication into a network-based solution. So as you kind of see on that graphic, is we really have kind of moved now from Industry 3.0 into this Industry 4.0 that we hear, in which we're having this IoT and networks. The idea is that we want to get everything onto this connected network. So we kind of fast forward or take this a step further and look at what today's connected model looks like. Is really kind of built upon these 4 solid pillars. We've got the things themselves that you can kind of see over on the left side. These are your PLCs, it's your RTUs, it's those end devices, cameras. Those are the things, the devices out there. Then of course we need connectivity, and then we've got to basically have somewhere to put that data. And then what we're trying to really do is get into the analytics. We're trying to basically process that data to make it into an actionable item. So we kind of take this into and really kind of put it into a little bit more of a visual, and what we're looking at is what today's network looks like, or a very standard network, or say a very basic copper network, as we've got these devices that are now networked together just with standard Ethernet cabling, or a Cat5 cable going into a switch, that now we can get our eyes on this or make this data actionable. So we have our things, we've got the connectivity, we're storing the data, now we can actually look at it. Now when we start kind of getting a little bit further down the road, and what the kind of the topic of today is this idea of hybrid networking. So what is hybrid networking? Well, there's a lot of different definitions out there. So in order to try and get us all on the same page, probably the most basic thing to look at is a hybrid network is just any network that uses more than one type of connecting technology or a topology, right? So we're basically, we just have multiple or more than one type of technology. And what allows this to happen is when you look at what this OSI network stack is, it's built upon layers. And you have 7 different, if you want to think of it as layers, or sometimes you can look at this in a pyramid. But really what enables this hybrid network to work is that these technologies live right down here at the very bottom of kind of the food chain. This is at the physical and the link layer. This is everything from defining, the binary transmission up through the kind of that MAC layer. That's really where we live. So we kind of take that and go into a very basic, or kind of the first level of additional networking or hybrid networking. We can take that same network, and now all of a sudden we can add fiber into it, right? So we've got basically, we still have our copper link in here. We have a redundant fiber optic network on top of that. This would be considered a hybrid network, kind of in the true definition of that. So we have multiple connectivity solutions to get to our things, devices, and then do some analytics on that. So when we kind of now take this forward a little bit further, in the industries that we get involved with, kind of in the industrial automation and the water, wastewater, mining, oil and gas, we're faced with different challenges than your typical factory floor. And so in order to do that, we've got these challenges that we have to overcome long distances. These can be city or county-wide coverage. We're going across waterways, we're going across roadways, we're going through mobile applications. Basically we're dealing with remote assets. So when we look at that same hybrid network that we had before, and then start spinning in some of these different challenges, what you can see is kind of down in that right-hand corner is we've got our base network, but we've got these remote assets now that we need to be able to get some connectivity to. As you can kind of see in that thing with these remote assets, that's the problem, is how do we connect to that? Well, ultimately, this is where wireless makes the most sense, that we can roll out and now incorporate wireless into that same network and bring this in. And these are our industrial mesh. For those of you that have been through the previous webinars, we've kind of gone into this a little bit more high detail, so we won't go into exactly what an industrial mesh is. But what we start looking at here is now all of a sudden we're combining, we've got copper, we've got fiber, now we've got a wireless link, and we bring it all into that same network to make that data not only accessible, but actionable. Now, the other part that we can kind of take to this even further is that we can actually now bring in, say, mobile devices, and these can be AGVs or maintenance vehicles, something that can be now roaming across that network, right? So when we look at this, this is really what we're talking about, and we accomplish this with our Horizon series. Now, kind of in a nutshell, what the Horizon series is this is available in 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz. And the other thing we've kind of talked about, but ultimately within wireless is in order to get something, we give something up. It's kind of a balancing scale. And so we can get higher speeds, but it's going to require more line of sight. All these within the Horizon series, we've got industrial mesh technology. And to kind of review it, this is what enables us to have redundant, self-healing, scalable networks. Each of these radios has multiple modes. It's the same radio that we can go into a very simple bridge. We can do into a router mode. We can do IP masquerading. Then we have the station modes, which allow this thing to now roam or to basically give us more flexibility and scalability. Basically, we can either have layer 2 or layer 3 networks. All the data itself is not only very flexible, but it's also very secure. It's very private, and we use AES 256 encrypted connections. It's very simply configured. It can be either through a web page or a Java-based utility. And then we also have an onboard memory module for rapid deployment or for ease of replacement on this. And if we get into the 2.4 gigahertz or the 5.8 gigahertz, this also has the common 802.11 Wi-Fi band. So you can now bring in your, say, your thin managers or thin clients, or you can bring a tablet into it. So it plays by those same rules. And again, we're kind of looking at this in 3 different frequency bands in that we have 900 megahertz, 2.4, and the 5.8. One of the things just to kind of backtrack a little bit to a previous one is when we look at those different frequencies, why would we choose one of those versus the other? Well, typically our 900 megahertz is going to give us a little bit better range, a little bit longer distance. It has the most line of sight flexibility for the unlicensed frequency band. So they can live with a few more trees, bushes, buildings, things like that can basically restrict our line of sight. This is non-Wi-Fi, so it can create a more secure network because we don't have any 802.11 access into that network. This is all proprietary communication. So again, it's much more secure. When we get into the 2.4 gigahertz, this is kind of the middle ground here, is that we can live with a little bit of line of sight obstruction, but now we can start increasing that data rate. We go from 72 megabits up to 150 megabits. We can live with a little bit of that line of sight obstruction. We do have some limited brand interoperability because of the Wi-Fi. We can have an ESTeem talking to a Cisco device as long as we have one as an AP, one as a client. This also allows that third-party devices. Then we get into that 5.8 gigahertz, in which we have the highest available data rates. This is where we can get up to 300 megabits, but it's very intolerant of line of sight obstructions. It does have also that same limited brand interoperability because it is part of the 802.11an world. Okay, so again, it's not necessarily which is the best, it's which is going to fit the best. Now, as we kind of go back to this OSI stack model, what we can see is that these radios sit basically right down here into those physical and the link layers. And so essentially whatever you can run across an Ethernet network, you can run across the radios. Now why I bring this back up is that this also goes into something that we can now roll out kind of in this hybrid model, but it goes beyond just introducing wireless into those networks. What we can also start looking at is how do we utilize multiple frequencies. So if you kind of look down and we basically blow up the view of that horizon, if you look at the front of this, you'll notice that we have 2 Ethernet ports on this. And so we've got basically what this does is that we add the first Ethernet port and the second Ethernet port and then that antenna port. Think of those as being combined into a bridge, right? So it all goes together. Those are all basically part of the same body. So as we start to kind of play this forward now we've looked at it, says, okay, here's our remote assets that we're now networking, but there's a lot of times in which we have, over a large area, we may want to break this down even further. So now, because of the ability to have those multiple devices in that same bridge, now all of a sudden we can take and split this. Now we can have, say, something like a 5.8 gigahertz backhaul to give us the greatest speed to it. And what we can do is we can use 900 megahertz to get into maybe a little bit longer ranges, or something that we're going to penetrate into some more of the vegetation or those trees. And we simply just link both of those radios together physically just through a patch cable. Now all of a sudden we have one network that's not only giving us the copper, the fiber going into it, and wireless, but now we can bring in multiple frequencies, right? So we can take advantage of the kind of the benefits of each of those frequencies to give us a better network. Okay, then we kind of take this even a step further, and there's kind of this question comes up, okay, what about if we have more of extended connectivity? What if I need remote access into that network, say from a different location somewhere, whether it's within just the other side of the city, maybe we're a different state, maybe we're in a different country, or we have a remote asset out there that's just too far to get with traditional radio that's been now brought into the link. Well, this is now where we're going to bring in cellular or an LTE router. And this is going to be done from an ESTeem standpoint, is we can now bring this in with our Edge Access Plus. Okay, so what this is this allows us to basically remote connect those networks. We can have remote access, we can do point to point, we can bridge these different devices into that same network. Basically, these create automated, self-created VPN networks. So everything is encrypted, everything takes the complexity and some of kind of the craziness of getting these things configured and makes it very simple. This device has onboard LTE, Wi-Fi, as well as copper. So we have kind of unlimited connectivity. It can be a Wi-Fi access point as well as a Wi-Fi client. This also supports layer 2, layer 3 networks, or kind of your bridged versus routed networks out there. And this can actually be an edge device that's simply feeding into your existing network, or you can actually take that data and put it up on the cloud, say something like AWS or Azure. That the choice is yours, it's your data. And most of our customers in the industrial arena are bringing that data back into that network. Again, these are all AES-256 encrypted links. So we kind of take this forward now and look at it, is we can now bring in that network. We've gone from a very simple copper network into, now all of a sudden we've got an edge-to-edge, completely connected enterprise. If you kind of look at the Rockwell terminology of the connected enterprise. Well, now all of a sudden we've got our copper here, we've got a fiber ring here, we're feeding into a switch that we can bring both the Wi-Fi or the wireless, kind of your traditional RF type networks in. We can also bring the LTE cellular networks in. This all goes into one common network, okay? I don't know if that makes, once you start looking at it, probably one of the better analogies that I've heard is it works a lot like plumbing. We're trying to get data, but we're going across multiple mediums, getting it from, that storage tank to your faucet requires us using different types of piping, whether that's copper or the Plex or anything else that goes on top of that. Okay, so it's kind of the same thing. We're just trying to flow that data, and we're using all these different technologies to do that. Now, as we kind of go forward in this, coming up in a couple of weeks, we're actually going to be talking about what we call a dual WLAN network. Now, what that allows us to do is that we can actually have dual networks completely isolated from each other running across the ESTeem network. We can think of it kind of as two SSIDs on your home router, but now we're doing this on a bridge device. We can run two separate networks. So maybe you want a process network, maybe you want something that's really designed to go forward and do something a little bit more for your general or your contractor work out there. Again, so this is going to be coming up in a couple of weeks on the 22nd. You can find the signups there on the website itself. It'll be out on social media also. So we encourage you to kind of join us and continue in your education side of things. These things again are something we kind of keep a little bit shorter, a little bit lighter, and then it'll be a little bit deeper dive into actually how do we pull some of these things off from a programming standpoint. And then if we've got any questions out there, I'd be happy to answer those. Get you going here. There we go. Whether you want to ask now, you want to shoot me an email, you can call us there, whatever works the best for you. Give it kind of a few seconds to see if anybody raises a hand. If not, I encourage you to kind of look at the website, and there's a lot of useful information there as well. You will get kind of a copy of this video of this presentation, should be shot out to you tomorrow. And if there's nothing else there, I thank you for your time and have a great day.